Imagine a world where humanity does not merely visit the red planet, but reshapes it entirely, turning a barren desert into a true second home. What if we took the dream of a Martian refuge to its most literal extreme and decided to rewrite the very climate, the very soil, the very sky of that distant world? Picture the planet's scarlet horizon, now overlaid with a lattice of glowing energy fields, each pulse a promise that the planet could breathe again. The question that follows is simple yet terrifying. How would we even begin to change a world that has been dead for billions of years? Mars has always been the prime candidate for humanity's next frontier. Its day length mirrors our own, its surface holds water locked deep beneath the regolith, and its gravity, though only 38% of Earth's, offers a tantalizing compromise between weightlessness and familiar pull. Yet the planet's average temperature hovers around -60 degrees Celsius, and its atmosphere is a thin veil of carbon dioxide, barely 6 millibars thick, far too feeble to sustain life as we know it. The first, and perhaps most obvious obstacle, is that icy, frigid exterior. One radical solutions have been proposed, each as audacious as the vision itself. The first involves a coordinated series of nuclear detonations over the polar caps, designed to vaporize the frozen carbon dioxide and release it into the atmosphere. Imagine a cascade of controlled explosions, each flash a spark that thaws a world, turning solid dry ice into a cloud of greenhouse gas. The second approach relies on engineering marvels placed in orbit, mirrors spanning 10 kilometers in diameter, positioned to reflect and concentrate sunlight onto the poles. As the reflected beams strike the caps, the dry ice sublimates, thickening the atmosphere and initiating an artificial greenhouse effect. In a rapid rise of several tens of degrees could follow, turning night into day and cold into warmth. But warming alone does not guarantee survival. Mars lacks a global magnetic field, leaving any nascent atmosphere vulnerable to the relentless solar wind. Without that protective shield, the newly formed carbon dioxide would be stripped away, escaping back into space at a rate of billions of kilograms per year. Moreover, liquid water remains virtually non-existent on the surface. The planet's regolith hides vast reservoirs of ice deep beneath, locked away from sunlight. To sustain any form of agriculture or mining, we would need to drill deep, tapping geothermal heat to melt these hidden glaciers and create localized reservoirs. As we contemplate these steps, the scale of the undertaking becomes almost mythic. Each decision carries a cascade of consequences, each solution a new set of challenges. The vision of a terraformed Mars is seductive, yet it forces us to confront the fragility of planetary ecosystems and the limits of our technology. If this glimpse into a possible future has sparked your imagination, consider sharing your thoughts in the comments. And if you feel the weight of these possibilities, hit that subscribe button so we can keep exploring together. As the thin atmosphere begins to thicken, humanity cannot yet afford to live exposed to the relentless radiation that still bathes the planet. Engineers therefore turn to colossal habitats that cling to the scarred surface, like shells of glass and steel. Imagine towering domes, each the size of a small city, their transparent skins shimmering under a sky that is still tinged with a faint copper hue. Inside, climate-controlled ecosystems mimic Earth's temperate zones, while outside, massive excavators carve out cavernous tunnels that plunge deep beneath the regolith, where the natural shielding of rock offers a sanctuary from solar particles. These subterranean citadels become the first true footholds of a Martian civilization. Within their walls, the red dust is not merely a nuisance, but a raw material of unprecedented value. The ubiquitous iron oxide that gives the planet its characteristic hue is harvested in massive furnaces, where it is reduced to pure iron and alloyed with carbon to produce steel of a quality rivaling that of Earth's finest foundries. Simultaneously, the silica-rich sand is melted in solar-powered glass furnaces, yielding panes that will one day line the interiors of the domes, allowing the faint Martian light to filter in while keeping the harsh exterior at bay. In this way, the very surface that once seemed hostile is transformed into the foundation of a new industrial age, a testament to human ingenuity turning adversity into opportunity. Yet the ultimate goal remains far beyond steel and glass. To make the planet truly habitable, the atmosphere must be enriched with oxygen, and the barren landscape must be coaxed into supporting life. Scientists therefore turn to the smallest of architects: engineered microorganisms. Genetically modified cyanobacteria, capable of thriving in low-pressure, carbon dioxide-rich environments, are released into the newly formed lakes that have begun to appear in the deepest basins. These microscopic factories perform photosynthesis on a scale never before seen, converting carbon dioxide and water into oxygen and biomass. Alongside them, hardy mosses and lichens, also engineered for resilience, take root on the once sterile soil, their green filaments slowly tinting the horizon with a faint verdant hue. Over the transformation that spans generations, the once crimson plains begin to show patches of emerald. Artificial rivers, fed by meltwater drawn from the thawed subsurface ice, carve gentle valleys through the ancient craters, while shallow seas form in the lowest basins, their surfaces reflecting the pale sun in a way that would have been unimaginable to the first explorers. In these new oases, humans can step out of their pressure suits, wearing only lightweight masks to filter the still, thin air, and feel the alien wind brush against their faces. The dream of walking on a true second home, without the encumbrance of a full-sealed suit, finally becomes a reality. But every triumph carries a hidden cost, and the Martian experiment is no exception. The planet's gravity, a mere 38% of Earth's pull, exerts a subtle yet relentless influence on the bodies that have adapted to it. After several generations, settlers begin to experience a gradual loss of bone density, their skeletal structures becoming more fragile. The heart, accustomed to pumping against a lighter load, struggles to maintain its rhythm, leading to an increased incidence of cardiovascular ailments. Children born on the red world grow taller, their limbs elongated by the reduced gravitational constraint, only to find Earth's pull overwhelming when they return for brief visits. Compounding these physiological challenges is a chemical menace that lurks beneath the surface. The Martian regolith is rich in perchlorate compounds, a highly soluble salt that, when dissolved in water, becomes toxic to human cells. As the newly created lakes and reservoirs expand, perchlorates leach into the water supply, contaminating the very resource that sustains life. Early colonists, unaware of the extent of this contamination, suffer from chronic kidney issues and thyroid dysfunction, prompting a frantic race to develop filtration systems capable of removing the invisible poison. The very act of terraforming, intended to create a safe haven, thus introduces a new, insidious threat that forces humanity to confront the delicate balance between environmental manipulation and biological safety. These unforeseen consequences serve as a stark reminder that altering a planet is not merely a technical challenge, but an ethical and existential one. The ambition to craft a new Earth forces us to ask whether we are prepared to bear the responsibility for the unintended side effects that may arise. Are we willing to accept the health risks, the genetic changes, and the ecological disruptions that accompany such a grand experiment? Or does the very act of reshaping a world betray a hubris that could ultimately undermine the survival of the species we seek to protect? In the final analysis, the vision of a green Mars stands as both a beacon of hope and a cautionary tale. It illustrates the boundless capacity of human imagination to dream beyond the confines of our home planet, while simultaneously exposing the fragile interdependence of life, environment, and technology. As we look up at the night sky and contemplate the red dot that has long inspired poets and scientists alike, we must remember that the true challenge lies not in conquering a distant world, but in stewarding the one we already call home. What do you think? Would you trade the familiar comforts of Earth for the uncertain promise of a Martian future, knowing the sacrifices that may be required? Share your thoughts in the comments below. If this journey through the possibilities of terraforming sparked your curiosity, please give the video a like and consider subscribing, so we can continue to explore the profound questions that shape our destiny together.